Uh, Hello, my dear students. Today we'll going to discuss a new topic regarding your chemistry for class 11 and 12. Okay, basically the subject or the topic is covered in class 12 of any board, any state board or CBSE, ICSE, etc. And this topic is very important for all entrance exam. It can be a medical entrance exam, or it can be a engineering entrance exam, or any other type of entrance exam in your college life and after plus 2. So you should focus very very much on this particular subject. So this is the rate of a reaction. Okay, and the name of this subject is chemical kinetics, and the main chapter is chemical kinetics. So this the main chapter chemical kinetics, and chemical kinetics, under this chemical kinetics, one subheading is rate of a reaction. Okay, so today we will actually look through the rate of a reaction, and we will look more elaborately the rate of the reaction. So what is the rate of a chemical reaction? You can say the rate of a chemical reaction rate of a chemical reaction. So, my dear student, look here, rate. So, rate is something change of something with the time per unit time. If the so what is speed? Speed is the change of distance with the time. This is the speed or velocity we can say. So here, rate of a chemical reaction means change of the concentration of the products or the reactant with the time. Rate of a chemical reaction actually means the speed with which the speed with which the reaction takes place. The speed with which the reaction takes place. This is the rate of a reaction. Okay, so uh, it can be expressed. It can be expressed. It can be expressed. It can be expressed in terms of in terms of the rate of decrease, the rate of decrease in concentration, the rate of decrease in concentration of any of the reactant of any of the reactant. So the rate can be described in terms of the concentration, change of concentration of reactant, and we all know the reactants are consumed in a chemical reaction, so its concentration gradually decreases with the time. So rate can be expressed as the decrease of concentration of any of the reactant. And if you express the rate in terms of product, then obviously the rate of increase, the product, the concentration of the product gradually increase. So the rate of increase in concentration of any of the product of any of the products. So let we have a example, general example from R to P. So R is the reactant and P is the product. So gradually the reactant R is will be consumed in and inform products. Okay, so its concentration of gradually diminishes and concentration of the product gradually enhances. Okay, so what will be the change of delta R? Delta R, change of concentration of R. So look, delta what will be the what will be the sign? What will be the sign of delta R? So delta R actually concentration of R final minus concentration of R initial. Final means after some time. Okay, so delta R is the final concentration of R, and Ri means initial concentration of R. Initial means not at the time t0, but initial means at the time from which you observe the reaction. Okay, so the starting of the observation, the time start for this time when the observation is started. Okay, this is the initial concentration, this is the initial time. Okay, so look, we see that as the time increases, the concentration of R gradually decreases. So obviously R final should be less than R initial. R final will be less than R initial. So what will be the sign of delta R? So delta R should be what? Negative. Delta R should be negative. Okay. So if so rate of the reaction, so rate, what will be the rate? The rate should be minus delta R by delta T. Why we take here the negative sign? We take here the negative sign because delta R itself is negative. So but rate should be positive. Okay, so rate cannot be negative. So as the rate is positive, so to make the rate positive, we impart here the negative sign because delta R itself negative. Okay, so rate is minus delta R by delta T. Okay, so please note down the things I have written in the whiteboard by pausing the video. Otherwise, you all forget this. Okay, and keep your notebook handy while listening my lectures. Okay, and my dear students, I must request all of you to please subscribe my channel and our watch our classes without skipping a single second. If you skip any single moment, you cannot fulfill your concept. Okay, your concept will be lacking. So this is the rate in terms of reactant, and now we are going to discuss the rate in terms of product. So similarly, very similar. So I am removing all this. So R to P. So R to P. Okay, so what will be the rate? Rate will be delta P by delta T. Similarly, delta P means delta P is the change of concentration, change of concentration of product, change of concentration of products. Delta P is the change of concentration of product. So what is the delta P? Delta P is the P final minus P initial. And here I must say, my dear student, while you are doing any change in chemistry on physics, always minus final minus initial. Always take the case final minus initial, final substance minus initial substance. So final concentration minus initial concentration. Otherwise, there will be a error in sign. Okay. So, so rate here delta P as concentration of product is actually formed gradually, so concentration of the product gradually increases. So concentration of the product, so p final always greater than p initial. So delta p, delta p should be greater than 0. So delta p should be greater than 0. So rate, what will be the rate? So rate will be delta p by delta t equals to positive. So here rate is the positive, but the rate is the same whether you express the rate in terms of reactant or product. Rate will be the same. Therefore delta, we can say that delta minus delta r by delta t should be equals to delta p by delta t. Okay. So actually this is the we can say uh, the concentration. Actually take the concentration in third bracket. Okay. So what happened, mm, if you uh, uh, the change of concentration of r, change of concentration of product, whatever, all these changes finite change. Okay. On and the change of time, all these changes are finite. So you can finite means there is the number has, the change has some weight. Okay. The change is large, not so small, not too small. The change is large. Okay. So this large change means finite change. And so when the changes are finite, the such rate can be called average rate. Such rate can be called average rate. And when the change is very small, delta t going to be 0, then the rate is called instantaneous rate. And then the delta t, in place of delta, we can write it d minus dr by dt equals to dp by dt for infinitesimal small change, for infinitesimal small change. Okay. So this is, you can say that this is the differential rate equation. Now we're moving to some more complex case. We are moving to some more complex case. Okay. And we can derive in that case the differential rate equation. You can say this. So d, these d's are differential, so these can be called differential rate equation. So differential rate equation in some more complicated cases we are going to look this. Okay. So people, if the reaction is nu1 A plus nu 2 B is equals to nu 3 C nu 4 D. So what is the nu 1, nu 2 and nu 4? All these nu 1, nu 2, nu 3, nu 4 are the stoichiometric coefficient. Okay, all these things are stoichiometric coefficient. So then the rate of the reaction, the rate of the reaction, so what will be the rate? The rate of the reaction R will be now in our previous case the in our previous case the stoichiometry was taken, the stoichiometry was taken 1, but here the stoichiometry has some values, okay, other than 1. Stoichiometry has some values other than 1. So in this case R equals to rate of the reaction equals to minus 1 by nu dA by dt equals to minus 1 by 2 dB dt equals to 1 by nu 3 dc dt equals to 1 by nu 4 dd dt. Please write down this equation. Look, here the negative sign appears only in case of A and B, because A and B here, A and B are the reactant. So the concentration of A and B gradually decreases. Therefore, the negative sign appears against the concentration change of concentration of A and B. But no negative sign appears in case of C and D, because C and D are the product, so its concentration gradually enhances. So no need to impart here negative sign. Okay. So now the factors. What are the main factors influencing the rate of a reaction? Factors influencing factors influencing rate of a reaction. Factors influencing rate of a reaction. I am not explain elaborately, but I am also I only write the factors. Number one, concentration of the reactant. I am not writing elaborately. I will discuss concentration, concentration of reactant. As the concentration of reactants will be high, the rate obviously will be high. Hmm. That means the reaction occurs with greater speed. The reactions occurs with greater speed when the concentration of the reactants is high. Conversely, the reaction rate decreases as the concentration of the reactants decreases. Okay. Uh, Number two, temperature. 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 Actually, temperature enhances the rate of the reaction. Why? Look, uh, a chemical reaction occurs. Please listen carefully. A chemical reaction occurs when the molecules of the reactants collide with each other. Okay, otherwise, a chemical reaction doesn't occur. So, to bring bring about a chemical reaction, the collision of the molecules should be occurred, and this collision of the molecules, the rate of the collision of the molecule depends on the temperature. As the temperature enhances, the kinetic energy of the molecules also increases, so its rate of the collision also increases. Okay, so as the rate of the collision increases, rate of the chemical reaction also increases. So we can say that with the increase in temperature, rate of a chemical reaction also increases. And it has been established, it has been examined that the speed of a chemical reaction, that is the rate of a chemical reaction, nearly doubles on 10-degree rise in temperature. So I can write it here. Uh, Rate of a chemical reaction, rate of a chemical reaction nearly doubles, nearly doubles on 10-degree rise in temperature. On 10 degree centigrade rise in temperature. Number 3, surface area. Smaller the particle size, larger will be the surface area. Okay, and faster the reaction, because the powdered form of catalyst is better catalyst, we know that. Large surface area means large reaction site. As the reaction site increases, rate of the reaction also increases. So smaller the particle, larger will be the surface area, and larger is the reaction site, so rate of the reaction increases. Number 4, catalyst. We all know the catalyst. What happened? The catalyst decreases the required energy for what? For what? The required energy for the reactant to go in the intermediate. So activation energy also in decreases. Okay. So catalyst catalyst actually speed up. Catalyst actually speed up, and it helps to attain the equilibrium quickly. Catalyst helps to attain the equilibrium quickly. Okay. So all these are the four main factors which affect or influence the rate of a chemical reaction. Okay, my dear friends. Okay. So we are going to solve a numerical problem. Whatever we have learned up to this, based on this, we can solve many problems. We can solve many problems based on this. Okay. So here given the rate for formation, the rate for formation of C, the rate for formation of C for the reaction 2A plus B C. The rate of the formation for the B C is 2 into 2 into 10 to the power minus 3 mole per liter per minute. This is the this should be the unit of rate. Change of concentration. Concentration means mole per liter with the time. So minute inverse per minute. So what is the value of what is the value of minus dA by dt? This is the question asked. If such kind of question asked in your MCQ, you will solve it easily. So what happened? The reaction given 2A plus B to C. So rate in terms of A, what happened? Minus 1 by 2 dA by dt. Isometric coefficient is 1 upon isometric coefficient, and this would be equals to rate. It is given 2.2 10 to the power minus 3. So minus dA by dt equals to 2 into cross multiplication. So 4.4 into 10 to the power 3 mole per liter inverse per minute. Okay. So by this way you can solve many other questions. Okay. So today we will stop here. In our next class we can see some more important topics on chemical kinetics, and till then study hard and goodbye.